Okay, so I think we're ready to go ahead and make the board. What you want to do now is go up to the board icon here and click it. It's saying that basically it doesn't exist, so you want to make it. Yes, we do. And here's the board. So let me just size this correctly. Okay, here is how Eagle starts off with the board. Each of the components are basically just kind of cluttered up into left to right sort. So this is the dimensions of the board, and these are the actual parts themselves. The yellow parts are the wires that run between it. So what we want to do is basically transfer each of these components over to within here, make the dimensions as small as we possibly can for this board, and then wire everything in. So let's start doing that. The first thing we'll do is we're going to change the dimensions to the size that I know it's going to fit in. And the reason I know it is because I already made one. So I'm going to totally cheat. So one of the things I mentioned earlier was the grid. Now the grid is much more important in the board. And this is simply the smallest step that you can move a part around. This is the default. It's kind of large for this kind of work. So we're definitely going to make it smaller. A lot smaller. We're going to keep it in inches for all of the work, and we will switch the grid on. We'll more than likely end up with 0.0025 as for the main size. How this works is this is the size you're working normally. If you press the Alt key, this is the size that it will go to. So then you can pick up a part. See that the grid's come on. So I'm going to go to the move command, and I'm going to click this, and you can see it's moving around basically on this grid. The crosshair here is, if I rotate the part, you'll see there's the crosshair on the left there is where the grid will go to. If I press the Alt key, bring it around again, it'll move a fraction of the grid. So it's basically 0.5, and then is the normal size, and then 0.025, which is half that step. Okay, so yeah. We really want to make sure the grid is kept properly. Most of the problems that people have with laying out boards in Eagle is because they don't get the components on the grid properly. Start to wire things up and things don't quite match, especially at the very small levels we're going to be working at. So the grid, really important. We'll just leave it at this at the moment, and then I'll show you how to fix it up later, because this is a fairly small board. So let's get back to figuring out the dimension of the board, the overall dimension. Okay, so the first thing we're going to do is break the first rule, because I'm going to switch to millimeters, mainly because that's what I originally created the board size in. So the only thing that I'm going to do this with is the dimensions of the board, just because I have to know what they are, and they have to be in millimeters. So let's do that. So basically this is just the size of the board. So I'm just changing this. Obviously I'm typing these numbers in because I know what they are. Not typically what you would normally do. I'll also show you the other way to do it as well. This is the actual size of the board itself, give or take. You see the grid size is slightly off on the size, and that's okay, because this is just a cut of the board, nothing else. Okay, so now that I changed the grid size to millimeters to create this box, let's just quickly change it back. Okay, so I said I would show how to create that box. So normally what you would do is you would just basically move things around. So if you wanted to make a box, you just simply do this. And if you need to know the length, if you click properties, which is what I was doing before to change the size, you can always see it. you'll see the length here, and that's the length in inches. You can change the style of the line drawing. The width should stay at 0 for latest, for when it goes to manufacturing, and dimension layer is what most board manufacturers use. Like Batch BCB use layer 20. I'm actually going to make another box in a different layer for the milling machine, but almost everybody uses 20 dimension layer. Okay, so let's set that back to the way it's was. Control Z is going to take that back, and that's going to be the size of our board. Let's start off with the chip, and again, instead of moving it, I am just going to literally put it at 0, 0, and I'm also going to change the angle just to make it look cool, and I'm going to smash it. And smashing it is when the label is able to be moved away from the package. In other words, typically the label and the instructions for the value move with the chip. When they're smashed, they don't. So there we go. So the chip is now moved to what was the center of the board. Originally the board was completely centered around the chip, but when we added the battery holder, it kind of added a little bit onto the end. But this is where it is now, so that's where I'm keeping it. And so now we're going to move the rest of the components. And to do those, we're actually going to use the move command and just move them into place. So here is opt1. We're going to drop opt1 down to the top side, just for the moment. Rough placement is fine. Some of these are going to be upside down. We're going to move this. I'm using the right mouse button to rotate it. Clicking on it with the left mouse button. Again, we're doing rough placing here. We can see the components. Now, when you do Alt F2, it tries to get everything in. Okay, so now that I have the size of the board figured out, I'm actually going to completely cheat and switch back to millimeters, just because that's what I like to work in. And I'm going to change it to 0.5, which means it's going to be very, very small. We're not really going to see that. So let's switch it to dots. Change the multiple to 2, which means it'll show it every 1 millimeter. There we go. So that's a little less cluttered. So the first thing I want to do is move the processor here, and I'm going to choose the processor. I'm zooming out a little bit so that I can get the properties box, which is a little hard to do. So type info IC1, and that brings up the position information, the name, and so on and so forth. I want it basically to be at 0, 0. I want to smash it, which means basically taking away the labels from the IC, and I can move them independently. I'm actually going to get rid of them altogether, but at the moment that's really what I want to do. The next thing is going to be changing the angle of it. I'm going to make it a nice jaunty angle, and there it goes. So the yellow wires have stretched to the original components. The CPU has moved to 0, 0. The white crosshair means is where the 0, 0 is. You can see it's added crosshairs onto the text. That means I can pick them up with the move command and move them away, because I am going to get rid of them by hitting delete, because I don't want them on the PCB. They will just get in the way. I'll leave that one there for the time being. So the next thing to do is move the rest of the components. Alt F2 again brings us out. I'll bring this battery in a little closer, because that means I can kind of use Alt F2 to do to show the whole image a little easier. And then I'm going to place each of the components. So to do that, you would just basically go back to move and pop it where you want it to be, which is here. I'm using the left mouse button to pick it up, and left mouse button to place it, and the right mouse button to rotate it. I'm going to stick these here. I'm just kind of eyeballing it at the moment. These ones are fairly important, so I can check here where I'm putting them. Yeah, I want them roughly about 9 and 0. So that's where I want it to be. Okay, now we're going to move all these guys over here, so there's a lot of them. And one of the things you can do is just simply type the name of the component with the move command and many other commands. And I want to start off with D0, and it will let me pick up D0. And I'm going to pop that down about here. Again, since I can totally cheat, select the properties, which is off screen again. But I'm basically using the properties command from the right drop down. Also going to look at 180, and that's where all the other ones are going to be from. So I'll move D1. I'm going to rotate it with the mouse, which is what you would normally do. And I decided to gap these, I think, at 1.5 millimeters. I apologize to everybody who hates metric, but there you go. So that's the one we're going to move next. So move D2, rotate it around, pop it down, move D3, rotate it, pop it down, and move D4, rotate it. Oops. Yeah, that seems odd. Okay, right. What's actually happening here as to why these wires aren't doing what I think they ought to have been doing that threw me off. I was expecting them to go to the next one because these are all actually joined together like these previous ones, and that's to do with what's called a rat's nest. The yellow wires are the rat's nest. Eagle will not optimize them until you tell it to, and optimize basically means shortest path for the wire. So when I optimize this, it's going to rethink all this wiring, and it's going to move things around so that the wires don't kind of go all over the place like they are at the moment. So there I'm moving D5, and you can see that one does kind of make sense. That yellow wire we're looking for is really close to it. I'm going to move D6, and you can just use the up arrow to fetch the previous command. Move D7. And there we go. So that's roughly about right, about where we want them to be, I think. Kind of double check that and look at the properties for it. And it's pretty much where I want it to be. Maybe a little closer up there is kind of where I want it to go. Move things around previously, but let's not worry about that too much. Zoom in on that. I'm just going to move that one up to 0.5. Just kind of tighten it up a little bit. So that's really where I want the gap to be. You can see I've changed the gap between those three to bring them in a little bit closer. Okay, so the next step is to move the resistors so that, in fact, so they all match to 2.5. I can actually just move these ones by hand a bit quicker. So I'm just going to tighten these up a little bit. I feel like I'm over tightening those, but okay, we'll take a look at what's going on. I think, oh, there's a resistor missing. That's LED, sorry, that's what's throwing me off. So that's good command. Good, it's just use the command. We're going to switch into the move mode. Use group. Left click drag, right click move group. And all that nice placement we just did has just gone away. And I have to totally guess where that was. No, I don't remember. Put those back. I think I just totally messed that up. Yes, I did. Those would be at 11. Yep. So group together. Again, move group. Line it up under that one. And that's better. Now we can pick up this remaining one, which is the one that has been making me think, why on earth haven't they all lined up correctly? This one is not on an even, because we are switching between metric and inches. So that's why this is happening. That's why you don't do it. There we go. Let's put it on there. Let's check that one. Yep, so that one's good. Okay, so the reason that last one didn't go in the right place is because I moved it back with the mouse instead of actually going into properties and doing it. Okay, so next let's move R0. And you can actually move these as well by telling it where to go with the actual XYZ value, or XY value. R3 next. I guess if you're a shell type person, you'll like this. If you're a GUI type person, I like shells. I can do it a lot faster than this. I'm doing it a slow way. Just mass, but there we go. Oops, I did an alt on that last one. Oops. Rotate and pop down. Actually, one more. Okay. Alright, numbering from 0 is probably catching me off. Okay, we're going to move C1 now. And that one's going to go over here. I'm also going to rotate that one nice to a nice jaunty angle. Let's see here. This one I kind of moved around a lot in the original design just to get it to fit in nicely, so that one's quite a specific value. Again, I was going for a particular layout. The schematic that I wanted is also going to be rotated, and there we go. And that's exactly where I want it to be. Let's check these guys as well. Where you put them is completely up to you, or whoever it is that tells you what to do. Okay, so we're going to mirror these two, so I want that to be 1 and minus 10, and that'll make it all nice and neat. Finally, the switch, which is S1, put that down about here. It doesn't really matter because, of course, I'm going to go in and adjust the properties, which is the info. Okay, so again, this is another very specific number that I have in mind. That looks good. And nice rotation, 315. Bam, there it is. Bring that down. Okay, lastly is going to be the battery holder, which is kind of interesting because it has the crosshair and it makes you think, oh, that's where it's picking up from. And if you try to move it, it'll beep at me. And the reason is because the cross is over there. So now I'm going to plonk it down roughly here. I'm actually going to go into the properties on this one again. And I'm actually going to go into the properties of the battery, not the wire that was there. And I'm going to place this one, because this was the an addition that basically screwed everything up. 1.5. And it's also mirrored because it's on the back side of the board. And there we go. For some reason the bat name is way over there. So let's smash that part. We can let's delete that text label because it's a very small board to fit this on. And that's basically the layout now of the board. That's where we want everything to be. So we check the jumper. It's 9. And that is what your layout should look like right now. Of course it is, right? Yours looks exactly like mine. So all we've really done is just place things on the board. I happen to know where the things are going to go because I laid the board out already. That comes through part of the schematic drawing. Now if you kind of look at this, if you can kind of ignore the battery and look at these, you'll kind of see the fan effect that's coming away from this chip. So these lines here, see how they're kind of going to the LEDs now. If we look at the original schematic, you'll see that same kind of fan that's going around. So there's the LEDs. But what's different about Doctor Who's schematic is that his goes 1, 2, 3, 4, 5 all the way around, so it's the numerical order of the chip. However, which isn't that uncommon, in our schematic you can see the numbers aren't there, they're grouped by the function of the chip. So you don't get that necessarily nice layout, so that's one of the reasons that I don't do it. Okay, so back into the board. So what we're going to do now is we're going to create the milling layer, because I keep forgetting about that. So once we've created the milling layer, then I won't forget about it anymore, and we can go on to actually routing the board. Okay, so video saved, and just talking to Adrian about the drinking game, which is every time I say basically, take a drink. If you've been doing that so far, you'd be dead of alcohol poisoning. So, some of you are already dead inside. It's true. Okay, so now I'm going to make the milling layer, which I should have done before moving all the components, but I didn't. So I'm going to copy these, and I want these. So I'm just going to pick those up. And I can't. This is one of the problems with Eagles that it's really. Oh, I've copied that twice. That's good. Finish that one. You can't see very well because of the crosshair. You can change that in the options, which is probably something I should have gone over at the beginning. I know I will do because Okay, so now I'm going to go on each of these and I'm going to change the layer to the milling layer, and once I've done that I'm going to explain what the layers are, which is probably a good idea. Maybe. I'll probably forget, to be honest. Okay, milling layer. So now the blue layer, it tells us that it's in the milling layer. I'm going to do the move command and I'm going to do group. I'm going to pick these up. Whoops. It's gone into Polygon select mode because I have multiple clicks, so let's see how well that works. And right click, move group. Whoops, I missed one, so pretty awesome. Obviously I'm drunk. Move group, try again, much simpler. And then just overlay over the top. And it's there, you can kind of see that half cast. So what happens is, the layers in Eagle are fairly simple concept. These are the top and the bottom of the PCBs. This is the copper, top side copper, lower side copper. The pads are going to be in this layer. The vias are going to be in this layer. Unrouted yellow. The dimension we talked about earlier is the dimension of the board that's all SparkFun needs. And then basically all of these ones here for different things like placement commands, orange, and they're mainly text. We don't really use them. T-stop cream is for when you apply solder paste, it tells it how much solder paste to put on it. Basically, it's a small hole that gets cut out, and so forth. Keep out restricts are basically ways of keeping the auto router and components and polygons out of places you don't want them to be. We'll use those later. Drills are where the drill holes go. Holes are just holes. Milling is where my milling machine will cut around the edge of the board. And then there's a whole bunch of other ones that aren't really used. T-silk is an important one. T-silk is where we put all the labels that we want to fit onto the board itself. So the printing of the white usually on the boards comes from T-silk. So we just care about those ones at the moment. Let's go back to select it. This is how you select it. So we're now on the top layer. You'll see it will change. You can also just do layer 1 or layer top, whichever you prefer. Okay, so the next thing to do, we've created the milling layer, so that will cut, the machine will now cut around here. The reason I don't use the white dimension layer is because sometimes when you set the width that we talked about before to a non-zero value, the milling machine cuts around the wire instead of cutting through it, which of course completely destroys the board. Hands up if you've ever done that. I should be putting my hand up right now, and it was a really big board and quite an expensive fail, so let's not do that. Next we're going to add what is called a ground polygon. When we mill away or etch away the copper, we normally have to take away anywhere there isn't copper, so we don't want to do that. And it's also much easier to route the board out with the wires and the routings where we draw the little traces. So what we're going to do is draw a polygon. And a polygon means that the parrot has left the building. So we're going to draw it around here. Close it. Okay, now it's going dot 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 like this, because it's not filled in, but we're going to name it now, and we're going to name it to the ground. And it's this polygon, this entire signal now. There's only this polygon at the moment, so all that matters. So what we've really done here is we've actually connected this area, polygon, which is going to be the whole board, to the ground layer, and anywhere that there aren't any signals or components will be considered to be a ground. So what else there is on the polygon layer that's important is the spacing. So we're going to go with 0.254 because I predetermined that number. We're going to isolate it as 0.4, and that is the distance in this case in millimeters away from the component. So there's going to be a gap of 0.4 around a component from the polygon. You'll see in a minute when I actually fill it in, it'll be a little bit more explained. We're going to leave the thermals on. Thermals are basically cutouts that it'll do where the components touch ground, like on these LEDs here are all on ground. And instead of just being a big piece of copper, it'll actually cut little holes, and it's kind of easier to put things on there. You see the name, there's the net class that's filled in for us, bottom, which is awesome, so it knows. It doesn't matter for a polygon, because polygons don't have a width as such. And then orphans are basically little tiny islands of copper that get left behind that can't possibly got to, so we don't normally have those on because they're just kind of ugly and they get in the way, but they're useful for some things like RF. So let's OK that out. Now I have my Eagle set up not to draw. It's called not processing the polygons because I don't like them to be filled in while I'm working. But while we're here, we're actually going to look at this. This is a really important setting. See, it even warns me about it. So normally it's not on for some ungodly reason, but always rectifying, always persistent in destroying. It doesn't really matter for what we're doing right now, but it will later. So that's always a good option to have on in Eagle, and it's something that we'll probably put on later. So here is the one, rat's nest process polygons, and what that happens is when I do a rat's nest command, which is what we're talking about, optimizing these yellow wires, it'll also fill in the polygons, and we'll see that happen in a minute. I usually have that switched off. So let's do rats, and there it is, it's filled them in. So there's the 0.4 gap of the isolation around it. It's connected up the LEDs, because they're on ground. It's connected up the ground of the battery, it's connected up the ground of the JP1 and the Opt1, and also you will notice that it hasn't connected to the chip. And the reason for that is because the 0.4 gap isn't actually enough, or it's too much rather, for it to get to the wire for the ground. So we have to actually fill that in manually. You can see this wire here, if I right click on it, it's ground. It hasn't joined those two together. Normally it would. If we change the isolation of the polygon to something quite small, it has a little drop down list here because it's fussy about the values. Not quite sure. You can see it's kind of filled it in. So it's trying to get there, and that's as close as it could get. But we're going to deal with that separately anyway. So let's go back to 0.4. Okay, the reason I went with 0.4 is it's a little easier to solder. It's leaving a little bit of a bigger gap here. I also increased the size of the SparkFun 1206 pad sizes. I felt they were too small, which happens a lot. It's okay if you're using machines, but we're all not using machines, except to cut it. Okay, so what is next? So next is actually going to be routing out the wires, and we'll talk about the auto router. Alright, so I think I've kind of covered everything in very light detail to cover. There's a lot more things to deal with we're just not really going to deal with, but everybody always talks about autorouters. And when I say everybody, I mean the people that talk about autorouters, and there's usually a couple of different responses to they suck or they're great. It's kind of both. The autorouters, most people use them in the wrong way. They do this. They type auto, which is for Eagle anyway. Change your routing grid, because that's how small it will grid around, and that's much too big for this board, so let's just even give it a chance of routing. So we're going to leave it like this. We're not having a bottom layer, so we're going to switch it off, not available. This is the direction that the wires will be preferred to go in, so up and down, left to right, and then diagonally, and then any way you like, and not available. Obviously we have to have one layer, so let's do that. Since most of the wires are going to go crosswise, let's do that. There's a whole bunch of options here for optimizing stuff, but let's give it a go and see what it does. So hitting OK will start the optimizer, and off it goes. And there it goes. I mean, it's done what it could. It's been unable to do everything, which is not surprising. It actually done quite a surprisingly good job, and one of the reasons we've done that is because we told it the net class size, so it's filled in these wires here. Remember we filled in the 20 mil before, so those are now going to be 20 mil, which if you do a quick conversion between millimeters and inches, you'll find is the right number. So it did a pretty good job, but you'll see there's no way we're going to get that through there. It's just not going to happen. So that's the reason that we don't use the autorouter in that way. I'm using the rip command now. Rip star means rip up everything. So all it goes away, all that hard work the autorouter just did, you know. And then other people, they'll come in and they'll say, hey, let's autoroute it with even smaller grid. Okay. Off it goes. It's going to work really hard at this. It's thinking about it. It's moving its things around, and it's still thinking about it. Basically tells us what it's doing in the corner. There we go. Which you can't see in the video because it's quite below. So let me move it up a little bit. Whoops. Is Windows helping me? Not helping? Or not? Okay, well you can't see this bit down here, but it's at 64% right now, and it's still working really, really hard. And so hard, in fact, it's going to take forever. So let's stop it. Going to run the rip command. The rat's nest command, which is going to fill in those polygons, and that's kind of where it got to. So you can see it's doing a lot better. It's actually doing a fairly good job, and that's because we followed the structure of the schematic. We lined it out there, so it is actually doing quite well, surprisingly. But there are some problems that we'll probably run into. Like here, it's going to be really hard to connect the ground planes together. We kind of want the ground plane there, but it has done quite a good job. But we can let it continue like that. It's wanting to save it now. So let's save it. Now you can see it moving the things around. It's kind of squaring things out. And look at that. It's failed miserably, but it's still quite good. All the grounds are all split up. These are the ones that are like right here. So yeah, that's what you'll pretty much get out of the autorouter. It's kind of what we expect, to be honest. The other thing you can do to help the autorouter is basically router. I'm going to use the route command, and the route command allows me to manually route wires, and it makes that lovely ding noise for some godly knows reason. So there I am, I'm filling in the wires. I definitely know where they're gonna go, and this is really the way I usually manually route. We wired these ones together, we know those ones for sure where they're going. Let's look at the switch. We're going to go in here and we're going to pick it. And we're going to use the right mouse button and it will move around. You see it's moving through the wire selections with the right. That's effectively what's called the next command. What I want to do is I want this wire here. That means I'm going to actually rotate this part, which is about, let's say about here. I'm going to run the rat's nest command. You'll see everything jump around. And then the route command. And the route command is basically the drawing part. I'm going to pick this wire cable here. And I'm going to say that my grid is just way too far off. So now I've changed my grid again. And we talked about going to a very small size. Let's make that about 10. And now you can see that we have that fine kind of control. It's probably a little bit too much that, to be honest. And now I'm going to move it around. And you'll see that Eagle will try to map it the way we want, but none of the defaults really work. So what I'm going to do is go into this mode and bring it out to about here so the lines are all nicely even, and just bring it in, and that's it. That's how you route a wire. And all we do now is repeat that over again. So we're in the route mode, and we're just going to pick up the wire that we want to route. So let's look for some more useful ones to do. We could start off with this guy here, which is R0. We want to go here, so let's kind of look around. Go, zoom in a little bit. Bring it. Try to keep it on the dots. That's what the whole point of the grid is. But the chip is so small. So I'm just going to do this. I'm just going to kind of bring that in there. And then I'm going to run the rat's nest command, which is going to fill in the ground plane. And there we go, look at that. Isn't that awesome? No, it's absolutely not awesome. So let's go back into the grid and probably do a little bit more, rip that up, root that. Okay, that's a little better. So we can do nice curvy ones as well. All kinds. So let's bring that to about here. Changing the modes until it's lined up. And bring it in. There we go. That's a lot neater. Let's do this one. This one, as it's technically called. Bring it down quite close, not too close. Again, this stuff I'm going to go over again. These are not laid in stone, they're laid in copper. Bring that over here. Isn't this fascinating? Yes, it is. And route this guy. I don't know why I keep retyping the route command, but I do. Now this one I happen to know a little bit about. And I'm going to bring it up here. Because of a specific reason. And bring it down this way. I think. Fairly close. Bring here. Okay, I'm going to skip the next one because that's part of the ground, which I completely failed at before about hiding. And this one I'm going to bring out very carefully because I don't want to touch the pin. I'm going to do the rat's nest again so we can kind of see. Back into route, which we were already in. Bring this one out. It's a nice easy drop down there. Same again. Okay, I don't want to get close to the... Okay, how are we doing for space here? Great, should probably start to come up from the chip at this point. Cut that guy off there, and there. Okay, wow, that's looking like something. I'm going to come from this side this time. And what I'm doing is I'm making sure that I get it really tight on there. That's the most important part because it will matter later. Try to avoid the edge of that switch, which I'm probably going to move, zoom out again, zoom back in to see what I'm doing, and bring it back in. There we go, look at that. Isn't that fancy? Here you laugh. Okay, nice and easy one. So let's look at where we want to go with this. Scope that. It's okay to come out of the side on this chip. I think it actually helps because it gives some strength to those pads a little bit. And then in here, we're just going to bring it to about here and finally there. Whoops, typo. Okay, who's next? This chap. Bring him down. Again, got to come cleanly off. Very cleanly off of that. I even think I might move that one actually. Don't think I'm going to get around that corner with that capacitor in the way. No, I'm not. So I'm using the rip command. The rip, click on it twice, it rips up the whole thing. So this time I'm going to go around here. I'll go around houses and bring that close. Yes. Oh yes. Should be able to bring this guy right down about here, sort of thing. And here, keeping away from that capacitor. We certainly are going to have to come back and rework some of this later for obvious reasons. And then let's have a look who's left. So we got this guy here, which is going to the, we can pretty much do a straight shot. Next is going to be, I believe that's the reset pin. Eagle's nice enough to highlight where we're coming from, where we're going to. I just want to say that I do want this guy to probably give you some space. I can use that, so I'll come out here a little bit, around here. And this part of the layer, I just want to kind of get a feel for where everything's going. Get that nice and straight. Bring it in. We're not using these two pins here because those are RXTX pins. There's an interesting one here which is up 2, which spoiled the whole thing by just being awkward. I'm going to bring this guy all the way around. Oops, kind of screwed up that last. Let's just do that one again. So okay, let's change the mode. Straight. I'm going to definitely want to keep up that. So sometimes what to do is just come out here and click that way that okay, I'm going to upset the pin, bring it around, should use a tighter grid down here, just like Google Maps, and here, and there we go. So that's tightened in our Polygon as well because it's basically cut off all of this area, so we may or may not want that. Now we've got the power to route here, which is the power. To do that, it's also set the smash ribs, goes to this capacitor, comes out here really nicely. It's a little thicker, so we're going to have to come in and change that because it's a global size for the net class for the power, but it's too wide, and you can see here. So what we're going to do is right click, properties, which you can't see unfortunately, and I'm going to change the width. And I'm going to change the width by switching back to 2 inches. for this is because the milling machine. So I know what I want to do. So I want an 8 or so. 8 will be fine. It's actually slightly small, so let's make it 10. So it's a 10 mil trace. There we go. And I think some of the so we can change the width to 0.01 on that one too. And that way, these are almost perfectly straight. There's a slight overlap on them there, so we might have to go in there and change those. But there's a tool for helping us to do that later. And there we go. We've pretty much routed out most of the board. What's missing here is ground, and the reason for that is because it can't come through here because of the Polygon can't make it all the way through here because of what we told it to do, which is the isolation. So there is going to be a reason for that. So let's switch my grid back, which you don't do. Leave it in inches. But and we're going to look at that Polygon isolation again, which is 0.4. So that should be fine. Let's have a look at here. Look at these here. And what we're going to do is cheat. So the Polygon can't actually make it through. We've got this lovely laid out board. So what we could do is just simply move one of the resistors. But it's actually the LEDs where it's stopping by the look of that. So the next thing what we can do is do a wire, the first one. So let's route that initial part out. There's a good reason for that. So let's bring it out. We're going to change the width on it because it's a number that I can't remember. So we'll have to switch back again. See, this is called being stupid. 12, good. And doing this part. Okay, roots. Could obviously do all that later instead of keep doing it. And you can see it following it around. That's called follow routing. Follow me routing. I'm gonna squeeze up here, and now it's added. And there it goes. It filled it in for us. There's still some wires unrouted, so let's take a look at it. So basically, we've got the same thing here. So we're going to take the wire from here, and we're going to go and route it up here. So we're going to fill this in. Bring that in. Bring that, and that's joined it to the ground plane. So we can see things are starting to heat up a little bit there. Okay, so we're going to try and get this to go over here to fill this in. So this Polygon here wants to be connected to that one, which wants to be connected to that one. The first thing we're going to need to do is just simply move it down a little bit. It's probably a little bit more than that. Just don't want to go too far, but it should be about enough. Okay, so that's filled that in. So let's see where that is. 9.1, back over to here. So it's minus 9.1. There, and you see what's happened over the corners. This wire has actually needs to be rerouted. So let's do that. And what we can do is we can actually pay attention this time to where that is and try and hug around that area. Okay, so hopefully when we do that, it broke it again. This one I happen to know is just very close to the edge, as we all are. So we're just going to slightly move it down very carefully. Okay, there we go. So that is now filled in this area, this area, this area, this area. We're still missing one, which is kind of... Where's that guy coming from? So let's take a look. Show ground. We're looking for the yellow wires, which are the unrouted wires. And we can see this piece here hasn't joined, which is where we really need because that's where the main power comes in. And this one isn't connected to this one because of the wire is in the way. So that kind of sucks because we want to move this wire. Let's try and get it so that both sides are filled in. So let's see, and it's kind of a little bit of, you know, give and take. We can calculate it, and I want to make that wire a little bit closer. Move it about. So I'm just using the move command. see it's starting to fill it in now. And Eagle is very specific about what it wants, so it's kind of easing it in there. Ease it in. Okay. It's connected that one up there, so we should have a pathway that's starting to make sense. The other thing I want to do is add a wire here, which I can actually use this cheat and bring that into the center pad and change the width. Which, guess what, going back, if I paid attention to what that number is after I do this, so I'm going to come to a 10, and we're going back to millimeters. Because I like millimeters. Okay. So we need to look at the ground grid again, and we can see that again this area is okay, it isn't being caught up over here. So there's a couple of ways we can deal with this one. The white one, and let's check that side. Not quite enough. Such a small grid size, you have to be a bit more careful about making things not quite. I can see how it's almost in there now. Almost, there we go. So now we know. Now we know. We can do the same thing on the other side, or we can just actually let's do this to keep it. Let me take the number of the wire. That's 12.7. Next, we'll take this to the whites and 12.7 and 12.7, so that it's all nice and symmetrical. And if we do this. It's all filled in now. There are no yellow wires that I can see, but the milling layer has to be changed as well. So we right click, next. Next is what goes through. 12.7. 12.7. Same here. I'm just going to the properties. Sorry, you can't see that. Okay, and now the blue has disappeared, so we're well within areas. So I actually made the borders slightly larger. There's a change I made to it in somewhere along, but so we've got kind of the basic gist of it now. It is, some of the routing is definitely a little bit weird, but what we can do is use the rip command, and the rip command removes individual parts if we use it carefully. You do it twice, use the RA, it will fill in. So now we can kind of go in there, zoom into it, and what's this command? There we go. That's quite lovely. And we can just straighten out some of those rather nasty little. But there we go, that's basically the board routing without using the order router. Now what we're going to use is a similar command to the ERC on the board called DRC. And, okay, there we go. So now we should have this part there we go. So there's the distances from wire to wire, 12 mil, distance from wire to pad, 12 mil, pad to a via is the hole that goes through the board, 8 mil. And then SMD, same signal, 8 mil differences, same pad, same differences. There's a lot of things in here, so, you know, distance from pad to pad. So this here nicely shows you what it's actually talking about. Now, distance, copper dimensions, drill hole to drill hole. Size is the minimum width of a trace is 8 mil, which we made to run some shoes. That's one of the reasons Matchfund can't like this board. Minimum drill side, minimum micro vias. We're not using multiple layer boards, that doesn't matter. Same for the blind. Via blinds. This here, the V-string, is basically to make bigger pads for the vias, and vias again are the holes that go through the boards. They basically connect one side of the board to the other side of the board. What happens is when you go to manufacturing, is the drills get slightly offset and they can cut through it. So what you do is you restring these pads and make them slightly larger, so that doesn't happen as much. I'll show you examples of that in class. These are for SMD pads. Just pretty much leave all this stuff alone. The mask you can change for if you're doing mask, but we're going to cover that in a later one. Let's see how many mistakes there are. Loads. Look at that. Clearance, 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 clearance. I'm going to move this off to the side so slightly so we can see what it's talking about, but here it is. And what it's doing is it's saying that these red areas are basically too, they can't be machined by SparkFlow. So we kind of know that because of the size that we're using. So one of the things I'm going to do is actually modify that DRC, because 6 mil, because yeah, we are that gangster. Half of what they That's going to help a little bit. There we go. Much better. So there you go. If you get a problem in the DRC, just change the DRC. Now it's saying overlap here because this is a ground signal, but it doesn't know what this is because that's in the part itself. There's an overlap here. This is bad. That's actually a short that I didn't spot before when we were moving that switch. Width here, I changed the width of this down to 10. We're asking for 12 mil. Same here. So these are the only three that are under that are under 12 mil. We know about them because we changed them, but the one that does definitely have to be changed was this guy. So it's approved. Oh wait, no, that was the one not to approve, wasn't it? So there's the nice command. You can go back and you can go, I disapprove of you, or disapprove, I disapprove of you. We do approve of you. Sort of approve of you. Yeah, okay. This one, most definitely no. So let's take what's going on here. The switch has interfered sexually with the via, or the drill hole. So we're going to move it away, like so. And then we're going to check to make sure that it is in fact run the DRC. Now put a semicolon after it means just run it and don't show us the configuration window. There's the difference. Now we'd have to do that. Okay, so now it's complaining. So we've modified something in such a way where it's broken that. And what's happened is that because I moved that, Eagle has now calculated that it can't make that pathway because it does stuff like that, to be honest. And all we're going to have to do is kind of jiggle around that a tiny little bit. Tiny little amount, just a tiny amount. And now it's back to normal again. So there's a lot of that in Eagle, and it's one of the reasons that we don't use it. So I'm going to... Can I just say that? Okay. Smarten that up. Run the rat's nest again to make sure it didn't affect that. And that looks fine. DRC. Oh, look at that. No errors. 4 approved errors, which is basically the same thing. Basically. Okay. Last thing to do is smash some of these parts. Smash these guys. Smash these. Because I don't want the silkscreen labels. Oops. I don't really think it is going to make me... Yeah, there we go. It just wasn't hitting. Let's smash the ISP as well in the middle. We're not going to have that. We're not going to have that because there's 2 of them. We don't want that. Let's smash this guy. And the reason I'm getting rid of these is because this board is freaking tiny. And remove that one a little bit because it's useful to have those. And we'll just put it there because it's quite lovely. All these guys have to go away, which I'm not going to do, but you are. And then the next thing I'm going to do is add text labels, and we're going to put them on the silkscreen layer. So we're going back to the layer command. Not the lasers, you know what I'm saying? So, T-silk. Text. Mo. Obviously everybody knows what mo means. I'm going to put it here. Change the size because it's too big. That one better? Yeah, let's go with that. And what these are the non-standard pinouts that I used. And you can see I'm using the text command, obviously. I don't think I actually explained that, but I'm pretty sure it's fairly obvious. Okay, look at that. So Eagle lets you use the bare minimum of letters to differentiate the commands, and with text, obviously, it's TX or T. That's the reset. So we're adding labels on the silkscreen. I changed to, and finally ground, which we're going to use G. There we go. Okay, so let's go back to the layer to make it a bit more confusing. I'm using the right button here to click through these because they're overlapping. As you can see, it's on T1 silk. It's unproportional, which is wrong, so we're going to change those to vector, even though I told it to always use vector, so probably wasn't paying attention to up here when I was laying them. But 121 is the silk layer, and what you'll see is if I say display, let's write the whole thing out. Display none, and then 121. It'll just show me the silk layer. So that's basically what will appear on the silk. We can add other layers. So CT18, WS stuff, and so on and so forth. Let's add the dimension in. So that's kind of roughly what the board would look like, with holes missing. And that's how it would print. So it's a lot neater looking. One of the problems is, for some reason, it's gone to the proportional fonts, which I'm pretty sure it says they're always vector font, but okay, whatever. And so we're going to go through and change these. And the reason that we use the vector font is because if you don't send vector fonts to all board houses, they get things all kind of messed up crazy, and you end up with just a huge bill for ink because they end up being really silly about it and printing out massive letters, which frankly aren't much use to anyone. So we're going to make these all vectors. So there we go. And then in Eagle we can press the F11 key, which is assigned here. I'm using it sort of default so that we can kind of see where it switches the layers on. So it does it an odd way, it switches them all off, switches a bunch on, and then switches some more off again, even though the none makes them all off. And there's some of the other commands that I've been using to customers, but you can do this, which shows you some information. You can notice it's kind of an overlap area here, but we're okay with that because we're not actually putting pins in here, and we're not actually even using that at all, so I really don't care. And there we go. That is the board to be made. The next step is going to be creating what's called Gerber Files, and we shall do that in a minute. Okay, minute over. So this is all very nice, it's all very pretty, but a long time ago someone decided, before computers, that they needed a different format, like DXF, if anyone remembers that, for sending these files to the printers and equipment that is used to manufacture boards. They're pretty much called Gerbers. They've been trying to replace them a lot of time and no one's been able to. So we want to go into the CAM processor. The CAM processor is basically what will take our board and convert it into Gerbers. We're going to select job. We're going to use the modified SparkFun one again. So this is a different one, and what it does is it basically allows us to define how each of the layers are going to be defined for each machine. Top copper is the top copper layer and what it's been made of, and we want it to be made of top, pads, and the vias, and that's it. So that's all that's going to exist in that information from those three there. We don't have a bottom layer, so we don't really care about that one. Top silk screen, we want T-silk, there we go. Top paste, we're not using top paste, and we're not using bottom silk screen because there's one. Top silk mask is T-stop, that's generated automatically. And then over here is the important one for us, is the milling layer. So I've already got that in there, and that's from my machine, which is the modified one. Drills and holes, that's fairly obvious. So the next thing to do, hit process job. It's wanted to save, so we save, and that's it. We have now made our Gerbers. So I'm going to close that out, and then we're going to take a look at the Gerbers. Okay, let's look at the Gerber file. So what we're going to do now is load those processed Gerbers, and wow, as if by magic, there it is. So this is the file that was generated. This is basically sent to the milling machine, and it'll figure out where to remove copper. All the black areas are where to remove copper, all the red areas are where to leave copper. Fairly simple, that's how it works. So each of the different processes and machines has a different layer that will generate that, and we're pretty much only interested in a couple of them. So let's turn this into something the milling machine understands. Okie dokie, so this is the milling machine software. It's not connected to the milling machine software at the moment, so it will miss some of the things out. We're going to import the Gerber files. This wouldn't be done by you normally, it would be done by the manufacturer, which in this case is me. So we're going to wait the milling layer, which is basically that blue line that we drew, and that tells us where to route. Then we're going to use the top top layer, which is GTL. Tell it it's GTL, and that's the copper removal part. And then we're going to use the drill file, which for some unbothered reason we have to import. We can see our drill sizes and speed rates. I completely ignored these, and Petty Larceny will yell at me probably. But there we go. So now we've got our board. We've got the yellow dots here where it's going to be drilled. We've got the blue where the copper will stay, the black where it will go away, and the kind of brown layer where the milling machine will route. It loads it in, and there it is. Look at it, and that's what our copper will finally look like. Now what's kind of interesting about it is that it's doing this thing where it's going to try to not remove as much copper, because removing copper is expensive for the drill bit. So what we do is we come in here and we pull away this, we run that, and it takes it all away and makes it all nice and neat. The other benefit of this is that it's much easier to solder it in. So at the cost of taking longer to mill and so on, it makes it way more easy to solder. Now you can see we made a mistake somewhere. This is diagonal, so we can go back and fix that. But we want to kind of look around here, like here is an obvious area of problem. The milling machine will spot this. If it was actually connected to the milling machine, it would show me that as an error automatically, but the software does not do that unless it's actually connected to the mill. I guess it's part of the upsell value. But other than that, it looks pretty good. So we'll definitely go and fix that problem there, because that will leave a little trace. The machine actually has a mode where it will say cut through there, but it's much better to fit it. But everything else looks kind of good. These pads are a little big, so we may have to go and redo those. We look at where the actual machine is going to run. You can simulate it. People probably see videos of where I've done it on there, but since I don't have the machine connected here, then that's about all we get to see. So there we are. That's what it would look like, and when we're ready to cut, the next step would actually be cutting it, which needs a machine, and we'll do that later. So let's look at submitting it to BatchFun, and they'll say we can't do this because it's much too small, but we'll do it anyway. Okay, so here we are at the BatchFun website. We've gone to here, which is just upload new design. So you give it a name. There's already been a cylon in here, so I'm going to call it that one. I'm going to browse the file that I created, which is just a zip file. That's what they want, is the text file, which is the drilling locations. Top solder mask, which tells stencil, where to tell it where to put the text. And then GTL, which is the top layer. So open that and then upload it. And that's it. And here it is. It's in roughly kind of what we were looking at before. It's top copper, it knows, top solder mask, and drill holes. And what I've forgotten to do is upload the text. It doesn't matter because it's not going to work anyway. So now here's our general board statistics. It tells us the size of the board, how much it costs, and how many layers in, and so on and so forth. We hit continue, and it will go here. In a little while, it's going to come back to me and say this has completely failed because here's one I did earlier, much earlier. Apparently so early, in fact, it wasn't working. And the reason it isn't working is because it failed. Oh dear. Here goes. So let's look at one that passed. The good FET couldn't make that. The original Proxmark couldn't make that 4-leg board. That's one of my designs for work. So the only one that's left is going to be the Scepter, which is a board that we're working on at NSL. That's what it will look like when BatchFun says it passed. So you look at the DRC bot, wait for it. It's going to be in there. Someone's run it an hour ago, so it's basically going to wait. It'll send me an email when it's ready to go, but I know it's going to fail. But that's basically how simple it is to upload stuff into Batch PCB, upload new design. Again, pick that, do that. Explains about all this kind of stuff, but we just use that file that we pull off the wiki and Sparkman website, and I'll show you how to set it up separately. It's probably going to take a little while for it to run, so let's look at something. So one of the things that I had on the original board was we put the NSL logo into the edge copper, which I do a lot. That basically works like this. We take text NSL, kind of guess the size, make sure it's a vector font, very important. And then we're going to change the layer, and we change the layer to 1, pick where we want it to go. It doesn't appear, and as if by magic, there it is. Now it's kind of wiped out this whole copper mask error, so what we're going to do is kind of jiggle it around until it fills it back in again, and there you go. It's got this horrible thing here, so what we're going to do is use the rectangle tool, and we're going to put it on T-restrict. I always get this wrong, so let's see. Okay, a little bit big on that restriction, but get the idea. So T-restrict is this layer that basically says don't put any copper here. If we run the DRC, we're going to get a whole bunch of warnings. It says there's copper in here, because we added it, but we know that, so it's cool. But that's the idea. I also use one on this because I don't want any of the copper to go in there, but in this case it hasn't actually gone close to it anyway. We want to keep this area clear to help this chip to sit correctly. So let's take a look at that problem that we saw, which I believe was going to be about here. So yeah, all we need to do is pick this up and move it ever so slightly. Grid round to it. That's kind of what we want to do with it. I pre-made this board in a much more detailed way, but I'm running for it. This is close, pretty close to the design that I already did. That's why I can do it. We show the miter command, I think we talked about before. Miter, spelled correctly. What that does is allow us to put little bends and be all artistic about it and make it look pretty. That's one of the things about PCB design. A lot of people do spend a lot of time making it look pretty. You shouldn't. Make it work. You can spend way too much time writing a board and fill in all the little tiny details. If it passes DRC, if it's electrically correct, that's all you really need it to be. Traces like right angles and stuff like that people talk about, but for this kind of level of work you're never going to care about it, and there's a lot of debate on whether right angles really do anything in PCB design anyway. The diagonal stuff like this one tends to be a little bit hard just because of the milling process. Think about the milling bit coming down here and turning. There's a lot more chances for it to actually be damaged, so or actually not that damaged, but just to be really mess that up. Just kind of to come in, see that a good way. There we go. Let's bring that actually like here. There. Okay, good. That's perfect. And there it is. I'm not really sure where we're going to go from here at this point. The batch PCB thing will be running and failing, but and we can go through some of the other stuff in detail in person. I think there's a lot more. We haven't touched a lot of the things that are in here. For instance, we haven't done the two-layer routing, which includes adding vias, which is pretty simple to do, but I'm sure we'll be having more classes.